So in this lecture we'll be studying cyclic codes. So cyclic codes are subclass of linear block codes. If I am saying it is a subclass of linear block codes, that means it should follow two properties. There must be a all zero code word in the code, and second, any two code words when added will result in another code word that is available in a code book. So why we are going for cyclic codes? Because if we go for higher order code words, if we remember that in linear block codes we have to multiply our data vector into generator matrix to get a code word. So if we are going for higher order code words, the matrix size will increase and it will be very tedious. So in cyclic codes we are going for the algebraic structure. That means our polynomial, we will be using a generator polynomial instead of a matrix. And the second thing is for encoder and decoder, in encoder and decoder we will be using shift registers plus mod 2 adders. Okay, so that will make our work go easy. So the definition of cyclic code says that cyclic code is a linear code, and second, a cyclic shift of a code word is also a code word. That means if we are taking a code word c of n minus 1, c of n minus 2 and so on, c naught, and shift it by left or right by 1 or 2 position or n positions, then if I am shifting it by 1 position, so on, c naught, cn minus 1, if this is a valid code, then this will also be a valid code. Let's try to understand this with an example. So an example is taken. Let's check whether it is a cyclic code or not. So for cyclic code, 3 properties must be fulfilled. All zero code word is available. Yes, it is available. Addition of two code words must result in another code word. Yes, it is happening. Okay, let's take another example. 110 plus 011, that is also another code word. So second property fulfilled. Third property, shifting of any code word should result in another code word. So if I shift it, I will be getting 011. If I shift it, I will be getting 110. So third property also fulfilled. So yes, it is a cyclic code. Let's take another numerical. It is a shortcut that Hamming code is always a cyclic code. Okay, so if I am taking a Hamming code with a generator matrix given like this, we will be getting a cyclic code. Let's test it. We have generated an encoding table in the last lecture of 16 code words. So there will be a all zero code word and all one code word. All zero code word, first property is fulfilled. We have taken a generator matrix, that means it is a linear code. Okay, so let's test the cyclic properties. So every code word with a weight of 3, when shifted cyclically, it will result in another code word of weight 3. Let's take 001 101. If I shift it, I will be getting 1101. I am shifting it by 2 positions. 1101. Okay, so 1101. I'm shifting it by 2 positions. So 0110100. So is it available in our code? Yes, it is available. So yes, it follows the cyclic properties of a code word. Okay, so till now we know that a code word will be something like this. Will be having n number of components, okay, n bits or n digits, c1, c0. So if I represent I shifted bits, shifted code word, I bit shifted code word, I digits shifted code words towards left as C of n minus 1 minus I, C of n minus 2 minus I, so on, C1, C0, and then I will be getting minus 1 and so on, Cn minus I. Okay, so if I represent this with a polynomial, so polynomial will be C of n minus 1 x to the power of n minus 1 plus C of n minus 2 x to the power of n minus 2 and so on, C1 x plus C0. So a code word polynomial will be of order n minus 1. Will be of order n minus 1. Similarly, a data word polynomial will be of order k minus 1 if we are taking a n comma k code word. Okay, so my code word will be C is equals to this. Okay, and I bit shifted code word will be C of n minus 1 minus I x to the power of n minus 1 plus C of n minus 2 minus I x to the power of n minus 2 and so on till C of n minus I. Okay, so coming to the first property. So first property states that remainder of xi into C of x n plus 1 results in I bit shifted code word. So let's take an example. I am multiplying x into C of x. I will be getting x into C of x, that is x into C of n minus 1 x n minus 1 plus C of n minus 2 x of n minus 2 plus so on C1x plus C0. That will result in C of n minus 1 x of n plus C n minus 2 n minus 1 and so on C1x square plus C0 x divided by x to the power of n plus 1 multiplying it by C of n minus 1. I will be getting this plus C of n minus 1. XORing it, I will be cancelling out this term, so my final will be C of n minus 2 x of n minus 1 plus so on C1x square plus C0 plus C of n minus 1. This is nothing but one bit shifted code word. Okay, moving to the another property. It states that C of x is equals to t of x into g of x only when gx, that is the generator polynomial, fulfills two properties. The first property states that it should be a factor of x to the power of n plus 1. Because we are using mod 2 adders, it may be stated as it must be of or x to the power of n minus 1. Second property states that the order of gx must be n minus k. And the third property that is not mentioned, that the gx will be maulic, that means gx will always be of this form: I is equals to 1 to n minus k minus 1 g of I x of I plus x of n minus k, where g of I is 0 or 1, either 0 or 1. So if a generator polynomial fulfills all these three properties, then I will be saying that multiplying it with a data polynomial, I will be getting multiplying this, I will be getting my code polynomial. Okay, so let's take an example. So a data polynomial is given, that is 1010. A data polynomial 1010 is given, and that is leading to x cube plus x. D of x is equals to x cube plus x. Now, a 7,4 code word is given. A 7,4 code word, that means a generator polynomial must be a function of x to the power of n plus 1. A generator polynomial must be one factor of x to the power of n plus 1. If we factorize it, we will be getting three terms: x plus 1, x cube plus x plus 1, and x cube plus x square plus 1. Both of these are molic, that means the highest order and the lowest order is available, highest component and the lowest component is available. So both of these can be used as a generator polynomial. I will be using this as a generator polynomial in this numerical. So c of x will be d of x into g of x. So x cube plus x into x cube plus x square plus 1. So I will be getting x6 plus x5 plus x cube plus x4 plus x cube plus 1. Sorry, plus x plus x. So if you see that these two will cancel out because mod 2 adders are being used, x6 plus x5 plus x4 plus x. That means the code will be 110, sorry, 111 654. 3 is missing, 2 is missing, 1 is available, and 0 is missing. So I will be getting a code word 1110010. We are just noting the components. 6 is available, 5 is available, 4 is available, 3 is not available, 2 is not available, then comes the 1 that is available, and 0. Okay, so let's try it again. If I multiply it with 0001, so let's take the code d is equals to 0001. So I will be getting polynomial equals to 1. Okay, so c of x will be 1 into x cube plus x square plus 1. That is simply x cube plus x square plus 1. Okay, so the code will be 6 is missing, 5 is missing, 4 is missing, 3 is available, 2 is available, 2 is available, 1 is missing, 1 is missing, and then 0 is available. So my code word will be this. My code word will be this. Okay, so just multiplying it with a generator polynomial. So remember, if we just multiply a data polynomial with a generator polynomial, I will be getting a non-systematic code word. You can see that 1010, you can see that 1010 was resulting in a code word 111010. The first should be a data, but this is not available, so this is non-systematic. Okay, so to generate a systematic code, so our motive is now to generate a systematic code word. How to do that? For generating a systematic code word, we have to shift our data polynomial to the left by n minus k positions. if it is a k polynomial, I have to shift it by n minus k positions. That means I will be multiplying it with x to the power of n minus k into d of x. Okay, so x to the power of n minus k upon d of x. If I divide it by g of x, if I divide it by g of x, I will be getting a quotient and a remainder. Okay, just for a quick recap, a generator polynomial consists of identity matrix followed by a parity word, parity matrix. Okay, so identity matrix, we know we can develop it. Only requirement is how to get a p. Okay, so if I multiply it with this, so I will be getting x minus k d of x is equals to q of x g of x plus p of x. This, if you recall the property, anything multiplied with generator polynomial, any data polynomial multiplied with generator polynomial, you will be getting a code word. So code word is x to the power of n minus k shifted bits of data plus p of x, where p of x is remainder of x to the power of n minus k dx divided by g of x. Okay, so just noting it down, to generate a systematic cyclic code, you have to find the parity bits. So how to find the parity bits? You have to find the parity polynomial. So the parity polynomial p of x is given as remainder of x to the power of n minus k dx upon gx, and code word is n minus k bit shifted data plus the parity polynomial. So you have to remember these two things. First is how to calculate the parity polynomial, and then after calculating the parity polynomial, how to calculate the systematic cyclic code word. Okay, so let's take an example. Okay, so let's take an example. If I have to generate a data is equals to 1 1, a data is equivalent to, suppose I am saying that any code word 1010. If I am saying 1010, and I have to calculate a systematic code word for this, systematic cyclic code word. Okay, so data polynomial d of x will be equal to x cube plus x. Remember, order will be k minus 1, that is 4 minus 1 3, x cube plus x. Now I have to shift it by n minus k, that is 7 minus 4. This is a 7 comma 4 code word. So 7 minus 4, that is 3 into x cube plus x. Okay, so I will be getting x to the power of 6 plus x to the power of 4. In this question, it must be given that what is your generator polynomial. So I am taking generator polynomial in this question as 1 plus x square plus x cube. Okay, so to calculate p of x, I have to find the remainder of x to the power of 6 plus x to the power of 4 upon x cube plus x square plus 1. Okay, so I have to find out this. Let's divide it. So x to the power of 6 plus x to the power of 4, x cube plus x square plus 1, x6 plus x5 plus x3, that will result in x5 plus x4 plus x3, multiplying it with x square, so I will be getting 5 plus 4 plus 2, so x square, x cube plus x square, again plus 1, so I will be getting x cube plus x square plus 1, so remainder is 1. So that means p of x is equals to 1. P of x is equals to 1. Just noting it down, c of x is equals to x cube into x cube plus x plus 1, that is x6 plus x4 plus 1. Finding the code word, I will be getting 1, 6 is available, 5 is not available, 4 is available, 3 is not available, 2 is not available, 1 is not available, and then finally 0 is available. So this is my code word. So my code word is 1010, that is data, followed by 001, that is parity. So just by doing this, we will be getting a systematic code word.